But if you can look at 3 level, you have one of the leg fails, you connect to 0, anyhow these capacitors were designed to take care of the neutral currents. Those capacitor midpoints, that's what we have done tons and tons of papers on it, saying that NPC, neutral point fluctuations and all of them. So these 2 capacitors were ready to take, and if you can see the space vector, you have already 0 vector and you have all redundant states sitting here. So all redundant states, thereby I did not to do lot of modifications, still I can drive with a kind of a 2-level inverter with this multi-phase. So within this hexagon, without having one phase, I can easily operate like a 2-level with 2 legs, maybe the number of switches may be more. So what I can say is that the complications will be diversified. It's not like what the same solution will work for the other phases also. So although it may be a kind of very easy for me to say, it requires some time because I been there for 10-15 years on it. Maybe for me it is easy, and of course majority of you maybe from students or something. See, it is very simple, the same thing, the fault thing which has to be connected to the neutral point, there is no doubt, and once you connect it, this leg is dummy, you can remove it. That means to say that A phase is only 0, the B and C phases can generate any voltages. So now you can say that A phase is 0, and you can see that the highlighted things, all of them will have a phase 0. You see all these 6 active vectors, 1 0 vector, all of the places A is 0 and B and C will be varying. Now here you see, you will definitely get a balanced supply, not like in the previous. Here the balance is always like very symmetrical. In the previous case you have seen 2 vectors with the different magnitudes and different angles. No, here it is not the case. Here it has 60 degrees, everything is maintained, everything is like no. Then what is the difference between these 2 things? Previously they were balanced, but the vector lengths and angles were changed, whereas here it does not require to change. What is the difference? You can bring it up. Fundamentals may be same, but harmonics will be different. When you try to do 2 vectors with a different magnitudes and different angles, you may match the fundamental but not the harmonics. In the previous case, harmonics will also going to play a major role. Here harmonics may not be less, that more. Here also it will be there. So what I am trying to bring into the picture is that it is up to you what data you want to synthesize to get an optimal solution. If you are only limited to the fundamentals, then our analysis will be something different. Something like your buck converter, boost converter, all of them. If you are only limited to your fundamental, the duty ratio between V0 versus Vin is only D. But when you go to small signal model, by looking at the ripple, it is not simple D, no. A lot of parameters will come, the root locus is there, now the entire world is there. So here also there are a lot of different complexities will come into picture. How do you handle it? This is up to you. With the time limitation, I am going a bit faster, but you can always So not only that, like if I say that 3 phase, 2 level and 3 phases, and again number of phases increases and all of them, I am not going to take care of entire thing. But now here you can see that if I go for a multi-phase, we have been working on a 9-phase system majority of the time. Like I believed initially, I don't know whether it will be successful or not. I believed that multi-phase will go on, so we started working on it. I have taken 3 multiples of n, that is the multi-phase which have been taken. The reason is that if I can have a 3-phase, my interest of doing is that modularization. Why always in terms of power electronics? Why can't I do a modularization at the motor level? Something like if I want 5 kilowatt, 3 phase, 10 kilowatt, 6 phase. What is the advantage of it? The number of slots may increase, the size of the motor may increase, the material may be changed, but the inverter setup, this is a conventional 3-level inverter, this is a conventional 3-level inverter, this is a conventional 3-level inverter, I can put it. And here for the simplicity, I connected the same voltage source, but you can have a different voltage sources for all of them. When you have different voltage sources, what will happen? You have battery pack designed for 5 kilowatt, you have inverter designed for 5 kilowatt, and the connections are designed for 5 kilowatt. So if I want to have a 15 kilowatt, that means 3 per unit compared to 1 per unit. I will get motor only will be designed at 3 per unit, but 3 sets directly I will take it and connect it. Thereby what is an advantage? This we thought in 2010-11 time, and of course now there are a lot of things, advancements happen. So my philosophy at those times that if car comes, only one plug point will be there. Assume that a bigger vehicle comes, that I will design a 6 phase, then 2 plug points can come into there. So I need not to upgrade the charging point every time, like no, instead of upgrading it, I can connect 2. If more than that, 3. The modularization at electromechanical level also can be done. This is what an idea. Anybody interested can be taken it up. And here fault happens, what is going to happen? Here the collision is here the issues will come into picture. Assume that if one of the leg fails, because of the symmetry, other 2 legs also has to be assumed. Why? Because in a space, assume that each phase is taken care by 40 degrees. Okay, one of the phase failed, then what will happen? It is something like our cycle. I don't know how many of you drove cycle, like no, not very fascinating, and the decathlon cycles kind of thing. The olden cycles which have been there for 1000 rupees or something, when you pedal it, no, at some point of time there will be something and suddenly it, you lose the torque and it again comes back. I don't know how many of you remember that, like no, you pedal it like no, with a huge torque and suddenly what will happen? There is a slip and then again it comes back. Just think in a space of 360 degrees. So 320 degrees you have magnetic field, everything is set. 140 degrees nothing is there. I cannot say nothing, but weak field or something is there. Then what will happen? The shaft which is rotating, it will have a lot of torque, and suddenly somewhere there is no torque, much enough torque. Suddenly it increases. Those forces where it will go? Those forces where it will go? When you are driving cycle, where those forces will go? Go to the knee. Suddenly the jerks has to be absorbed knee. Similarly, vehicle, the shaft was been having a different forces, if not balanced forces, that translates to the bearings. Because the immediate shaft, that bearings will collapse. You go back and look at the fault scenarios, bearings is one of the major culprits in the failures. The reason is that when you don't have equal forces on it, and any imbalanced forces will translate to bearings, the bearings can get failed. So that is the reason I have to maintain symmetries. If something is there, something like shaft, whatever the force reduction happened, the same amount of force reduction has to happen at 180 degrees. If both were been pushing on the both sides or opposite sides, both has to be equal. Otherwise, what will happen? One side it will shift. The bearings are going to be there. So what are the torques? Other torques? Then you have to rotate this tangential force or whatever you want to call. That forces also has to be equal on both the sides. Otherwise, what will happen? One side is going to be higher. The other side is going to be. It is simply like in physics, our class teachers could have been told that you have both sides 1 kg and you rotate, it will be balanced. One side 1 kg and other side there is nothing. And when speeds are going up, you know how without knowing you will be moving on that 1 kg side. Okay, the same kind of stories which are going to be happen. So to maintain the symmetry, we have to avoid those things, and we have done it. So without disconnecting also you can do it, but okay. Now you can see that how it has been translated. This is a 9-phase vector diagram, and you can see that 3 kind of triangles has been translated this to this. So I say that all A phases become 0, and this B and C phases, the second set of B and C phases, third set of B and C phases. Now you can say that this shift has happened. You can say that what should I can study out of it? What should I do it? Now if you can see here, all the neutrals are sitting at one place now. If you can look back here, all the neutrals, this N1, N2, N3 more or less at the same potential. Now you say that one winding to the other winding you have a slots and all of them, no, there is an insulation. If this same voltages, the insulation requirement will be less. Whereas in the next case, what has happened? This has been shifted. When the neutral voltages are shifted, where is the voltage stress will go on? There should be insulation, has to be ready. If you want to make the system to be fault tolerant ready, you have to have ahead of calculated insulation, it has to be ready for it. So how much of insulation is required? Like, no, what is the time duration we have to handle it? Because you know the insulation breakdown times and all of them, that is also going to be very, very interesting problems to handle it. This a conventional things cannot be taken it up. Like, no, there are a lot of data you have to study and all of them. This is another approach, and of course this you can go ahead like anything, like, no, there's some other faults has happened, something like in one of the phase A and there's another B, then you can see that what is the shift in the neutral points. Previously what has happened, this neutral points was been fairly a kind of distributed here, but when it has happened, faults happen in two different locations, now you can see that the insulation requirement is going to be huge. That's what they say, that inverter grade motor, grid grade motor. No, what is the difference? The insulation only. And of course, there are some harmonic capabilities and other things, but the insulation. So what I am trying to say that when you want to design something, majority of research are going on post-mortem analysis. That AML, my key stress, I don't know whether I failed to give that underneath the information message or not. I am trying to be vocal on that. My message is that we have been always using AML after post-mortem. Some event has happened, you collect the data, and after the collecting data, what has happened. So I think we also have to think introducing AML into the design level itself. So if this is the case, can I reduce the operation somehow, like, in the control? That is also we have been working on it. So this shifts can be balanced to bring it to one level. Can I do some kind of control algorithms on it? I don't know how to do it, but like, what I am trying to say that you have to add some elements. One is the design aspects, the physical components which has to go to the motor level can also be used with a lot of data, what you can be doing it and what is their characteristics, bringing into the picture. What is the runtime you have to be aiming for it? As I said, that the runtime need not be the lifetime of the motor. In the fault, it is only for 1 hour, 2 hour, 1 hour, 2 hour. What is the overloading has to be taken? I cannot say that because linear relation I cannot bring it to it. So when non-linearities are there, that is the best time to bring AML. This is one thing. There is another case, you can say that, like, no, other phases happened, A, B and C. The multiple legs have been failed, still the motor can run. So you can see that this disturbances, why I am saying is that by now I don't know how many of you visualized, these stresses were distributed. If you can see here, this one side of the set of A and this is C set, B set was been separated, whereas the other case A and this is something like first and the third set and second set was isolated. So are a kind of far away. You can say that why should I worry about it? So just for the students, you know, transform windings, how it will happen. Transform windings, we think that the primary is one side, secondary is another side, no? But actually how it will happen? One and another. And one and another when you are trying to do, which will go first, which will go last? Primary will go first, secondary will come last, no? What is primary and what is secondary? Low voltage first, high voltage comes last. Why? Insulation requirement. So it means optimization is there by our blood. Core is, we assume that the ground potential, and from core to low voltage you require less insulation, and already you have built certain voltage, on top of it that the higher voltage will be lesser than that. That means when we have been optimizing at inverter level, transformer level, why can't we do here also? How do you do that? Where there is completely certain, you don't require to do anything, but here you can do much more analysis. That's all my point is to say. And of course, when we are doing this, I could able to say that the fault analysis, you can put it, at least some of the faults with very generic thing, you can see that this big table was been there. This I am talking about only 9-phase 2-level inverter. Just think about 9-phase 3-level. You can say that, sir, who is going to be using it? I believe that there is no other alternate. Already people started multi-phase. I know people are working with 15-phase also. The reason I will tell you, sometime back also I told, the number of slots in the conductors, the conductors in the slots is same. Either is a 3-phase or 15-phase. Now the number of phases were increasing. What is the volt per phase? Reduced. When it reduces, DC bus voltage requirement will come down, which is not advantageous. And all our devices were ready to take higher currents than higher voltages. Paralleling of device, here paralleling also can be avoided because of multi level windings and all of them. So what I am saying that we cannot escape, like no, already people are started working like no multi-phase and on top of it. And of course there are a lot of other advantages also I will try to bring into it. So that means to say that if it is only 3 level and 9 phase system, you have these many combinations. So this analyzing post fault is fine, but how do you be ready to be handled at the time? What are the optimizations has to happen at the design level? Starting from insulation to a kind of windings, to a kind of connections, and to the inverter switches, and to the batteries. Why batteries were required? Because at the fault times, the signature of discharge currents will be different than the regular working condition models. The working condition, the discharge signatures will be different, and in the fault conditions, the discharge signatures will be different. And if you are going with a very conventional monotonous battery discharge SOCs and all of them by thinking that the current signatures will not change, then entire your analysis will collapse. Okay. So it is very simple. No, you can say that sir 1 hour what will happen? It says that like no, it is 1 hour fine. Like no, we always think that sir I have a fever. So delay by 1 hour of paracetamol, what will happen? Nothing will happen. But when you are in ICU, that 1 hour delay, you know what kind of impact it will happen. Like no, the system is already in fault condition, and you say that like no discharge pattern I don't worry about for 1 hour means that's it. Like no, this is a cascade effect. No, one failure can go for another, another can go for another, everything can be collapsed. Okay, that is the thing which I want to put, that there are a lot of complications. And how to do it? Yes, I am also working on it. This huge potential on it. Of course, we capture something, but that I cannot present it because my student is also working on it. Their work also going to be there. So why I am giving it as very raw data is that everybody of view aspect is going to be different. I picked up something, but I am presenting the problem as it is. Somebody can pick it the problem the other side of it. Now that is only the solution. Can I do something else? There is another thing, something like no, two faults has happened somewhere. Like no, what will happen? These hexagons will be a kind of phase shifted. Those hexagons can be something like a dodecagonal structures will come into picture, asymmetrical dodecagonal structures. This is also a popular studies. You can go back and to look into it. When it comes into picture, there are a lot of mathematical computations will come into picture, how to operate. I didn't do that mathematical things. By now itself you can see that when symmetrical, everything is easy. You have been seen like no space vector diagram implementations. You always says that cos alpha by whatever, that sine of alpha minus 60 by sine 60. Some relations we bring it, no. That is in the symmetrical condition. Asymmetrical condition, the magnitudes is going to change, they based on the phase angles and everything. And when asymmetrical things comes, how do you get a balanced supplies out of it? It is also going to be huge complicated things. Okay, this also can be, this is a postmortem again, like no, how do you able to operate it? This is something like in the previous case, the fault has happened in one set. I don't know how many of you noticed, in one set only one phase got failed, but whereas in the other case there are two sets got failed. Then how do you operate it? That means to say that there are a lot of the possibilities and to get a different control strategies into picture, and this definitely require a lot of mathematical computations, especially when asymmetrical things were come. Then that is the place where one can look into it. I hope another 10-15 minutes. Question answers I'll take. Okay. Huh? After this, maybe I have to download that paper. And, this paper only you can download. Yeah. So this asymmetrical also is not in the same in nature. It depends on the phases. Like no, the asymmetrical comes into, they may look the same, but you can see this axis, y-axis. You can see how they have been shifted. That itself will give you a lot of analysis. So you can imagine the complications. First you have to identify the fault, which phase, which location, what is the time, and from there what kind of vector I have to select, is the previous kind of scenarios, then I have to rearrange the connections without coming down, and the operator has to go, and otherwise if that is not the case I have to select this, and the entire control logic has to be changed. It is not like existing control will work now. It is not the same DTC, it is not the same vector control, it is not same hysteresis control, or nothing will work. Then you have to be redefined something with very lightweight program kind of thing. This is what I said, that lot of data and AML can be placed. Now, of course, we have done some analysis just to show that how the air gap, flux and phase voltage, all of them, because without these waveforms it is something like not full, no, tummy will not be full. So I thought of showing some waveforms. And I can say that if multiphases happen, just now I said no, it was something bit easier, like no, in the previous case. So here you don't require, everything will be symmetrical in nature, like no, you can get this hexagon, but only thing is that they shifted, but the shift will be in line with the phase windings. They have been 40-degree phase shift, and the same 40-degree phase shift is going to be coming there. But this is only for 3 level. When it goes for more levels, and if it is a 4 motors, 4 inverters, you know, how do you synchronize that? That is also very important. Something like, I will tell you another gamut which I can say, that now you have a 4-wheel drive, 3 motors, 3 inverters are fine, 1 inverter is not working. Then this is in non-linear nature. Based on that, the other 3 has to play a role. And synchronizing that non-linearity with this linear systems is much more difficult. And also you cannot lead any force onto it. Okay, so that is another major thing. This is another aspect. Now see, I am slowly introducing the 3-phase multi-level, then multi-phase and multi-level, and now this is another thing which I am trying to introduce, the complicated thing, like not complicate, this another add-on degree to it. This is something like a pole phase modulation MMM drive. So here the same motor, because this is a known concept for us long time back. So sometimes I will have a high pole and sometimes I will have a low pole. I will try to modulate the same motor. Sometimes it will have a higher pole, sometimes it will have low poles. What is the advantage of it? When I have high poles, I am going to get high torque. When low poles, low torque. It is very simple. It comes with speed is equal to NP by 120, and speed into torque is equal to power. If number of poles increases, speed comes down. If speed comes down and power is constant, torque has to be increased, vice versa has to happen. Now how do we do that? Why this is very important for us in electric vehicles? Electric vehicles, at the time of starting, you don't require high speeds. What you want? High torque. At the time of running, I require high speeds, not torque. So I should able to, medium torque, not very high torque, some medium torque. Similarly, at the medium speeds and high torque at the initial or low speeds or whatever. So to achieve that, you can always see that the mechanical system with a gearbox, this is a typical curve which you are going to get it in gear 1, 2, 3, 4, 5. This, not this, is it a pink color? No, it appears like pink color. Yeah, not that. The black ones is the typical torque speed curve of your IC engine coupled with a gearbox. Now I want some kind of thing like which is connected like this. I should able to get this kind of curve from my motor. So to do that, what we have done is that something now poles and phases got changed. You can match it. So, but of course, I didn't do 30 pole. Sorry, what I can say that higher number of phases. This require a huge number of phases. I think 45 phases. We didn't do it, but this is theoretical concept. But pole phase is there from ages. It's not like very new thing. So here, what we did is that how do you do that? It is very simple. You know that how the poles has phased. I said that like no, that the current was going in this direction. This is one flux, and this is one flux, and this is another flux, and this is another flux. There is nothing else. Like no, it was like going on. So now you can see that if I want to introduce the number of slots per pole for phase, we do know when you are doing the winding diagrams, number of slots per pole for phase. So I assume that there is a 3 slots. and all these 3 conductors are carry current in one direction, all these 3 currents are carrying opposite direction. This is what we will do in spite of that Yp, front pitch, back pitch, +1, -1 and all of them. Finally it end up with all the things. If you go back to the core essence, within these 3 slots will carry the same amount, same direction of the current. Magnitude of current can change based on the phase and all of them, but the direction will be the same. Now this is like this, no, this is a 2-pole system. Now assume that the current for this conductor was going on like this, assume. Now if I change the current path only for this, what will happen? The current will go on this, current will go on this. So this will produce south pole, this will produce north pole. Then 2 poles will divide it into what? 6 poles. 2 poles will be divided into 6 poles. Just I change the current in this path, you can just see the color change has happened. Now what has happened? This is same direction north, it has been changed the direction, it becomes south, and this become north, south, north, south. So eventually 2 pole become 6 pole. If it is a 4 pole mission, it becomes 12 poles. This, and of course you have to have a generalization, you cannot do it very randomly. There is a philosophy you have to follow. We are kind of blessed. We have published a paper way back in 2014 where we got a chance to redefine the generalization. There was a small error in the generalization which was there for longer times on this pole phase modulations, because not a new concept. So we could able to correct the existing generalization to a kind of new generalization philosophy. We could able to brought it. I've been lucky that I could able to present in front of Nedmohan, Professor Nedmohan, no more. Yeah. So this once it is there, so that means to say that if I can able to properly manage, the same motor will work it as a 4 pole, same machine will work it as a 12 pole. So that I can use it for starting and regular thing to avoid the gearbox mechanisms. To achieve that, it is very simple. In a conventional machine, like now I have taken half of the sector, 36 slots out of 18 slots. You can say that excitation 0, 20, 40 and all of them, this is a 9-phase operation, and 12 pole operation is something like 0, 60 and 120 and 180. This, how do you excite it? Because the inverter legs were there. It is something like this. A phase, this is also a phase, this is also a phase. If I give 0 and 0 and next phase, I will get 20 degrees or 60 degrees. If I give a 20 degree phase shift, it becomes 3 phase. 60 degree phase shift, it becomes 9 phase. Okay. If you not understand anything, like no, okay, whatever it has gone over, like no, it may be sometimes confusing. Just trust the angles between mechanical and electrical. There is some relation, no? Theta electrical is equal to P by 2 times of theta mechanical. Just see here, this is mechanical assume and this is changed 60 degrees. What has happened? P by 2 is 3, that is number of poles has multiplied by 6 times. 6 times or 3 times? 3 times. So that means to say that P by 2, not P by 2, 3 times, that means here it is 4 pole, it becomes 12 poles. So with this, the advantage, as I said, that how it is possible, this A phase, B phase, C phase, D phase and all of them which are phase shifted by 40 degrees, that becomes 4 pole. Instead of 40 degrees, this is 0 and this is 60. Just now I have given that table, no, I do not remember. 0 and 120 and 240, because that is a negative conductor. Yeah, it is 0 and 120, 240 and again 0, 120, 240, 0, 120, 240, then that becomes 12 pole 3 phase system. Because why 3 phase? Because this is a repetitive in nature, 0, 120, 240, where the other case. So here the advantage is that here I have a legs or in my control. So legs can control either 0 voltage phase shift or 120 degree phase shift or any phase shift which have been asked. That is what we are doing from beginning. Okay. So this is also possible. So as to summarize, you can say that A phase 0, B phase 40, 80, this becomes a 9-phase 4-pole, and just change the excitations, this itself will change the number of poles which can produce a high torque. Now you see that you don't require any mechanical system to change the speed torque characteristics. I can only do the excitation change in the inverter legs. That is easy, I have my own microcontroller sitting there. What is there? The changing phase angle is, triangle is anyhow constant, like our heartbeat. It will never listen to anything like of course sometimes it listens to few people. Other the case, the triangle will be constant. On top of it, what will happen? You will compare the sine wave. Say that how others were thinking In that time the modulation is in the linear zone, we are happy. If it is an over modulation, always we worried because they are not caring for us. We never think that we are much above than that, they cannot care about it, but we are always worried about it. Mainly for Gen Z I am telling, because anyhow they are sleeping. Okay. So what I am trying to say that the sine wave and triangle wave, the comparison, the sine wave has to be phase shifted whatever the angle, and that can able to take care of it, and this is one good thing. And how the flux distributions are going to happen, this is the thing. Now I am saying that here also when you change 4-pole to a kind of 12-pole, it look like okay, you change the current, it got the number of poles. But if you can closely watch it here, you can see some color difference here. There is some color, and you can see some color difference here. What is that color difference? Flux density. Flux density. Because you have designed a motor either for 12-pole or you design a motor for 4-pole. Now this is the time the same motor has to work for 4-pole and same motor has to work for 12-pole. That means the flux density at each slots will be varying it. That is what I witnessed here. You can see some of the places where the flux density is high, some of the places have been less. So how do you design the core for to accommodate these two extremes? And on top of it, these conductors, we always assume that the top and bottom conductors, I hope, I strongly remember strongly believe that some of you could have been done. The leakage flux of your windings will be depends on the placement of the conductor on which side, inside that or the top side of it. We could have done in the induction motor deep bar systems, trying to replace one bottom conductor and one top conductor will do it. That kind of luxury we may not have here because the number of phases were increasing it. So how do you handle that leakage inductance? You say that why should I worry about it? If you don't worry about that leakage inductance balancing, the currents which is going to go, it is mainly depends on supplied voltage minus back EMF divided by this leakage inductance and resistance only. This leakage inductance was not balanced. If you give the same voltage, because same is speed, back EMF is same, but the currents in the each phases can change. Why this is important? I says that when you are working with several motors, the synchronization is going to play a major role, and it's a humongous data and one can able to think on it. And this is one major concern. The code designed to a kind of operating principle to leakage inductance control to several things we can do it. Yeah. So I said that coming to end. Oh, I think I rushed it. Okay. Maybe I have to give paper and I'll take questions and answers. The thing is that where our AI we can able to think about it. How do you handle faults? Especially design I am not giving design, of course you require an extra thing, at least if not designs, how the faults can happen in multi-level, multi-phase and pole change or induction motor or any other motor. Can I get, because the same signatures may not be there at PMSM. Induction motor is the most friendly motor. You know why? If the pole changes in the stator, nobody asked me a question. Luckily, the rotor also poles has to change, no? It is natural in induction machine. That too, it is in the squirrel cage only. In slip ring, it will not happen because they have dedicated windings. Squirrel cage, what will happen? Every end ring they will be connected together. This automatically current changes, poles changes, everything changes, but not in the slip ring. So, if not in the PMSM definitely the physical poles were there. How can I change it? That means to say that the complexity on every mission, everything is going to be changed. Now I have seen some of the papers where they are coming with a combination of permanent and sir? No, please. Electromagnetic, yes. The permanent magnet and electromagnetic combined together, because PMSM also, people think that PMSM is the great help. PMSM is great help at the time of starting, but higher speeds, you have to demagnetize it. You have to demagnetize the rotor flux. Demagnetizing the rotor flux or reducing the lifetime of permanent magnets, which is another big issues for going on it. So it is nothing like one is good, one is bad. That is the reason they are coming with a permanent magnet and electromagnetic both together to address these issues. So what I am trying to say that this definitely there is lot of data. My motivation to come here is that don't look all the time the other side of it, like no, only on superficial, like where okay, this has happened with that data, what I can do, there is a traffic, what I can do, if there is some signal systems has to be, yes, that is also good, but sometimes you look at these aspects also. There are a lot of challenges in our own vehicle. Okay, so what can we do it on top of it? And I have taken only examples from my lab, whatever we have been worked. I didn't carry any other papers because those papers are available with you also. Of course, these papers are also available, but I can be confident while presenting it. That is the reason I have taken only my lab data and I've been presenting it. So remaining things, I'll leave it to you. I'll be open for the questions. Yeah. So mainly I have been looked at fault tolerant operations of pole phase modulation. If not pole phase modulation, multi-phase, multi-level, or multi-phase 2-level, or 3-phase 2-level also for electric vehicles for various missions, something like BLDC missions, axial missions, SRM missions, you know, you think about PMS missions, any kind of missions, everything has their own signatures, how to handle it. This is also going to be a very interesting thing, you can look at it. This is what my thought of presenting it. In between I rushed it because thinking that like I may be delayed. Any questions, I'll be more happy. I think 12:40, another 10 minutes and then the paper, I'll download the paper and give it. Any paper.
Capacitor set which is required to maintain is one set is enough for all phases.
Yes, yes. Yeah, I didn't.
We have to create another logic when fault diagnosis happens. The winding has to be connected to the zero voltage.
No.
So there we need again control.
Yes.
When it is a good condition, it has to be connected to the
yes. Yes.
When it is having a fault diagnosis,
that has to be connected there.
Again we have to build
yes.
some control logic.
Yes. 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 It has to be experimented. Yeah, nice point you have pointed. If it is a 3-phase, what has happened? I assume that all these things were not there. The entire A-phase current was going here. But whereas all three connected here, this current and this current and this current, 3 currents were going on, but they are not in phase components, they are phase shifted. So then the current going to the capacitor is not an algebraic sum, it is a vector sum. Vector sum always lesser than algebraic sum. So the currents will go here will be lesser than a conventional 3-phase machine. This is also another advantage. I didn't go in that detail, like who been there they can look at it. So this is also another advantage if you want to design that. And of course not only this, it is very simple. I will give you another example. Why should I connect here? Because I want a 0 for this voltage, is it right? Instead of connecting there, just I will connect to this because this is only in fault, this is not in fault condition. I will make 50% duty ratio, then it will not give a 0 voltage, it will work. But what is the difficulty there? The ripple component is different for this winding compared to this winding. That ripple component, you go back into the small signal. I don't know how many of you remember induction motor equivalent circuit. For ripple, what will happen? The secondary is short circuited. Secondary side is short circuited. Then it's going to be huge currents. How do you balance those currents is also going to be very important. If anyone of you remember that, like no, otherwise what will happen? R2 by S will come in the secondary side. No, that is for the fundamental. For the ripple, what will happen? That power loss, we assume that 0 for ripple. Just ignore that R2 by S. Then what will happen? That is a dead short circuit. So you are introducing harmonics to one and not to the other. Other you are trying to give a pure, and this is like a brother and sister. They will always fight. Like no, you have a pure and I don't have a pure voltage and harmonics. because harmonics will be more at that 50% duty ratios. Yeah.
Have any standards for this fault tolerance levels?
No.
Like level 1, level 2, level 3, like how
No, at least
stars. So if I am buying
no, at least what
is it instant for level 1 of fault?
No, what my understanding is that now they are thinking the fault is that what oversizing you have done. Something like 20 degrees it has to operate, minus 20 degrees they may be designed, or you have to carry 10 amperes, they may be designed the conductor for something like 1000 amperes or kind of 200 amperes, thereby it can be stand. But not, if fails, an alternate mechanism was not there, at least. This I am talking about alternate mechanism. Something like a conductor has to carry 10 amperes, I will design 100 amperes. Then they says that the buffer I have more, so then the probability or reliability concepts will be increased, but not post fault operations. I am talking about that. I think this has not been standardized or anything. In my point of view, maybe they have to, yes, yes, huge, huge, huge.
Fault tolerance and alternative mechanism is different.
Yes, yes,
alternative mechanism has,
yes. And also design aspects to fault no handling capabilities. Yeah, fault tolerance. These are the two spaces not has been explored much. Yeah, I felt that like a lot of labs are coming and we are also kind of doing it. But sometimes when you are taking all these things, you have to make sense to the others to get it accepted first. So that may take some time, like no, but this is the space which you really want. And I'll tell you, for the new generation also, even one problem you solve it, your next 7 generations are solved. You don't worry for the campus placements or anything. So I remember like no APC when I was working, there's one director, he told that in 1980s there was one problem in the regular UPS, 1 kilowatt, 2 kilowatt UPS, whatever we are using it, that was being burning very frequently. He has changed one resistance. That's what he told me. I don't know, he could have been done something. One resistance, that model became very rugged. Only thing is that he didn't believe the PA controls of textbook way of saying that the inputs has to be the same gain, same resistance and all of them. He changed it. And that become like very reliable, and they exported it to outside countries also. And with that he became a director, and like he had his own R&D wing and everything, like and of course I'm not undermining his capabilities, I'm not undermining his success, I'm not attributing for the small thing, but you have to see that identifying that at right time, right occasion is very, very important. And I hope this is a time for us to explore. The reason is that we have a huge pressure on permanent magnets. We don't want to have PMSMs. Okay. And at the same time, we are in the kind of you can say whatever false prestige or a kind of socially driven or whatever, like no, we don't know why we require a BMW. We don't know why we require a bigger cars. Nobody cares of the safety. Nobody worried about their own discipline in driving. Nobody worried about anything. The next guy I had a BMW, I have to have a Audi. We don't, inside home we may not have AC, that's okay. We don't have a proper sofa, we don't want, but we want to have ventilated seats in the car. I say that how much time you will be there, like no. Hardly a kind of 1 hour per a week, and you have to invest 10 lakhs on it, which you are not going to use. I could able to clearly see this is what social economical, the base variant versus the full variant, it is more than double. The base variant is 9 lakhs and the full variant is 24 lakhs. What are you getting? Basic rings, safety is same. At least when we are buying a 2013-14, some of you will agree. The basic version doesn't have AC, doesn't have ABS, doesn't have a collision systems, doesn't have anything. High end used to have a AC, music system, that ABS, anti-collision systems and all of them. But no, basic system to advanced system is there. What is changing? Ambient system is changing. The color will go like traveling. And it says that how many of us were going on back, what engine has been used? What long it will be there, that we have not done. That means to say that our ambitions of the luxury is also increasing. And in this passion, we don't want to be dependent on others to decide what we want. And I think this is the space where we can think about ourselves and design something new. And say that nothing will come on the aid. No, nobody can do a magic saying that this is the motor, it can work for all of them. Like, no, in the process of it, we all have to work, and somehow you may be lucky or I may be lucky. Like, I've been hearing that Alfred Rufer story. I don't know how many of you looked at. He is not the one, not Alfred Rufer, yeah. Nobel story. This, Alfred Nobel. Alfred Nobel is not the one invented that explosive material. His professor is the one who explored. He went to that lab as a trainee and he looked at okay, this can be packaged. What he did is that he packaged that explosive material in safest way. You see, it looked very odd to listen, very unsafe material to pack it very safely. You look at recently that BBC also, it has been there. So it was very unpredictable. Sometimes it will blast, sometimes it will not blast. The reliability was not there. And you don't know how to carry it also. So what all he made it is that he made it more reliable. Whenever it has to blast, it was blasted. And whenever it has to be done, it has to be done. That's it. Like, it says that we don't know what is going to be clear, what is, and of course he also, like, no, with the last stage he had his own trouble. The other great guy, Tesla also, what he did in transformer, like, no, you made it, like, no, he effectively used that principle of electromagnetic induction and effectively used, and of course last days he also could not able to pay the hotel bills. No, there. I think that those two are the two legendaries where our lifestyle has changed. The Nobel is the one who we could able to witness all the roads and all the buildings. The basic stone is from him, and all the luxuries what we are enjoying. This all the way radio, telephone, lighting, and everything to a kind of Tesla. So it is not that the great things came. Small things has been evolved into a bigger ways. And of course, I am not advocating that everybody will be like that. But at least we have more chances to work on it.
As you already mentioned, AI has to help. Somebody has to explore and create the data.
Yes.
Then only AI can help.
Yes.
Otherwise, AI doesn't generate its own.
Yes. If it is generate
such a faults, we have to explore and we have to give data to AI.
Yes.
Then afterwards, the decisions will be AI. So AI cannot.
By alone it cannot. No, if it is do, it only can generate a garbage. Yeah.
We don't know what
you cannot believe it. Yes. That is my philosophy of bringing it. And finally I want to say that I am not telling you that you only look at these problems and this only can generate. I am trying to say that you look at anything, but somewhere you have to start. You don't start that something is available. You look at the system and generate this data, and you look at what to be addressed, what not to be addressed. You don't address because somebody is addressing that issue. Somebody is working. Maybe when you have a pressure of doing promotions and all of them, you can do it on project. But when you don't have pressure, just look at, okay, what I can generate something new. What I can generate, which will be there. Who? Student. Oh, you are finding that kind of student. I'm also student. Don't curse me. Just smile it and enjoy. No, my son is also 10th. I know how I'm handling him. Because they are very clear what they want. We are the, I think, like, no, I can take my age somewhere. At the age something like you believe that something will go wrong if I don't get passed. I say that I know some of the students who came to me on my face saying that, okay, I don't write. No, I seriously, I challenge, like, no, this is very good. Sometimes one student came to me when I'm teaching 13, 14, I was very aggressive saying that, do that. One student came to me and said that, sir, why you are not studied signal processing? Why you are not studied image processing? Why you are not studied AML? Those days. This is that I could not able to understand. I understand power electronics, I studied. I am also not understanding power electronics. Why are you cursing me? Why are you pressurizing me? And I also don't give, no, I'm also, then you tell me one area where you are interested, then I will leave you. You come back 1 year, 1 hour or 1 week, you tell me that I am focusing on that. Go. So students were very clear, like that way we should admire them. Yeah.
Present generation, they have their own lines.
No, but that is also required. Otherwise, like you see on the developed countries, what is happening? Like they don't have work. Puzzle mind, yeah, deviate. Yeah. So at least our generations were peaceful. They want to satisfy their mother and father dreams, or they want to act like they are listening when somebody speaks. Yeah. No, I am also bad student. I am backbencher. I always say that like no, 35 marks were good for me. I told you, the more celebrating guy if I get above 50. Say that above average guy. Yeah. Any other questions? Become more philosophical.
Flux density depends on flexible area.
Yes.
In that induction mode,
Yeah.
area of the core is already fixed
Yes.
at the time of measurement.
Yes. Yes.
And flux in the core is depends on current in the
Yes.
line.
Yes.
Then if that occurs, difference in flux.
Yes. Yes. Yes.
At that time, hotspots will be
Yes. Yes. Yes.
that will get
Yes.
near to that inflation.
Agreed. Agreed.
Will lead to the that leads to
Yes. For that reason, for that reason only we have been seen that we have seen how serious that flux density has been increased. So rather than taking a 3-phase core, we have option to take either 3-phase core or 12-phase core. We were not going in both extremes. We are optimizing the core requirements between 12-phase versus 12 pole versus 4 pole. Somewhere you have to optimize it. Manufacturing itself. That's what I am saying. Like no, we have to come out at the first time. And also while taking this right question you asked, just I'll assume that if I am trying to design a vehicle, I have two versions of designing. Vehicle for the city traffic, vehicle for the highway traffic. Now it came, no. Everybody has two vehicles, one for the city small car, one for bigger vehicles. So now my 12 polar mode operation will be heavy if I am going on city traffic. If I am going on a highway traffic, that means very luxurious car for longer drives, I may not be going on 12 poles, I will be going on 4 pole. So I should able to identify what is the operating time for 12 pole and 4 pole if I am running for 1 hour. If you know that the drive cycle curves will be the typical drive cycles, like 20 kilometers how much speed with its inclination and all of them. So you see that if I am driving the vehicle for 10 hours and I am only using the 12 pole mode only for 1 hour, that to a span of certain times. So why to a design for 12 pole? You understand, it is not like something like it was continuous been going on. This is what I say, that ambiguity we have to bring it, because out of 10 hours if I drive, only 1 hour I am using 12 pole, because 90% you will go in the 5th gear. No, 5th gear means 4 pole only. That time anyhow flux density is less, very less time only hot spots, even if it creates you have to come back. This is what I have been telling, like at least I will give you some interesting thing to you people. So aircraft you have seen, no, you have traveled by flights, you have seen two engines for their next two aircraft. What do you think their capacity? What is the power capability of those two engines? A rough number? Megawatt? Close to 40 megawatts. I think both together. So have you been seen any thermal power plant of 40 megawatt? Definitely require 20 to 25 acres. Not even square feet, 25 acres will be there, 25 to 30 acres. Then how could I able to they accommodate with that small size, that 40 megawatt? Overloading. They have been heavily overloaded. That is the reason while takeoff and landing, they will ask you to wear the seat belt. The reason is that why you require 40 megawatt? Because when vehicle is moving, if it is a car is only have to give a kinetic energy. The flight require kinetic energy plus potential energy. That is the reason they first attain kinetic energy, then some of the kinetic energy and the engine they will use it to climb the potential energy. And when they know that when they are climbing, they are overloading the engines and they are going to be heated up like heavily. I don't know how many of you seen while sitting in the next to the wings. Once they reach to certain altitude, they will release all the pressure in the engine. So you can see that sound like it has been literally taking away from that time. They even open the chambers from the engines. Even at the time of landing also, once it touched, not the wings, on the engines, they will open the chambers. Once they go outside, how it has been sustained, once it goes to outside ambient temperature is minus, not the plus. So you don't require any cooling mechanisms. So you take the advantage of environment where you are working. Like while landing, you can ask me, sir, while landing also there will be a kind of huge temperature, but after landing, what is there? You wait for some time, let it cool down and then do it. I don't know how many of you seen, at least you watch sometimes. This is what you have to do. When blades were there, the blades angle they changes to get the zero friction, to heat, cool down, and all of them they will be trying to do it. I don't know, because this is a patent thing. It is not that I worked and I can give you the exact solutions what have been done. But this is what my observation. When I am sitting there, rather than watching a mobile or something, especially for you people, look at it. Just very simple thing. You are going in a lift. Somebody is jumping on a lift. What could have been the current profile of the motor? Somebody standing and going on, there is a steady curve. If somebody is jumping, then what will happen? The mass will be changing, no? That means you are pushing some kind of steady state current to a transient currents. That is the reason nobody will allow you to jump that. It is not because of the mechanical forces. Of course, mechanical forces, typically they say that don't jump in the lift and all of them, no. One of the prime reason may be mechanical, but mechanical will take care of it. But this currents are going to be shooted up like anything. If the motor burns, no. And especially sometimes you should not do all these stories, because I'm living in 40-floor building. And when kids were jumping, no, it always beats my heart. Okay, yeah. There are a lot of challenges. You can create a lot of things. AML, don't look at very superficial. This is what my message to convey to today. Okay, for that I may be taken a bad example or good example or something. My message is that if you want to do something, don't wait event happen and do the postmortem. You go aggressively and look at what you can do it at the time of design aspect to operating aspects to implementation. Yes, that is also yes. Yeah. Thank you. Yeah. Any other questions?
Questions from the participants.
Yeah. Thank you. Thank you.
Paper, sir.
Yeah. Paper. Can I take this itself as a paper? The pole phase modulation thing? Pole phase modulated induction mission.
Yes, that only will do.
Is that is okay? Pole phase modulation mission?
Yes.
Yeah.
You disconnect, sir. Show the paper.
It is there with you?
Yes.
Downloaded? Ah, well, thank you. So, thanks for listening, by the way. No.
You will share that paper till
Immediately I could not able to get in EA algorithms or something like that.
yes.
I thought of showing it this. Time కూడా దొరకలేదు నేను కూర్చొని చేస్తుంటే
Because AML is, as you told, superficious. First, we should have to give the basic understanding. That is much required. Not see the things in full phase modulation based multi-phase induction.
fine. but this is maybe a tougher paper like. Paper also talks about the same 4 pole to a 12 pole. Okay, here what we have done is that here we have added like, no, because I already discussed about this thing, just adding a little bit more, because at the time of starting you require more energy, no, because you have to give a kinetic energy for the entire vehicle to move. So that time I have two options. I can design these batteries to discharge more, something like when I am igniting the car to start, those batteries were discharge faster but charge very slow. The discharge will go all the way to 100 to 150 or 200 amperes, but charging will happen in only 1 or 2 amperes. But whereas your UPS or mobile batteries, they charge faster but they cannot discharge faster. So typically these batteries are costly, where kind of charge faster and discharge slower. Where similarly extreme the other side also, discharge faster also costlier, like, no, this in between you have to be there. So now if I want to see that at the time of starting, I have to pump lot of current because I want more torque, no, I have to pump lot of current. So instead of that, what we did that, I'll divide into two parts. One is to majorly to take care of the steady state, one is to take care of transients. Transients, that means at lower power levels, low speed applications, low speed high torque. Low speed high torque, I know that 3-phase 12 pole is the high torque. So 3-phase means what we did is that 3-phase 12 pole in this operation, we made this, we know that this is 0, this is 0 and this is 0. This is a 3-phase 12 pole operation, the excitation you can do. So now what will happen, all zeros has been connected to a kind of one winding this side, the other zeros in the other side. 120 is also been connected, all 120s, you can see this node, 240 is also connected. So that time what will happen, although it appear like a 9 windings, this 0, this is 0, this is 0, they are one and the same. 120, 120, they are one and the same. That time means this is one side inverter, this is another inverter, this becomes an open end winding multi-level inverter. So I can extract more current from this, less current from this. And once it go to steady state, what will happen? Now this excitation is going to be all this 0, 140, 180, 120, 160, 200, 240, 280, 30. And what you do is that disconnect this current. I don't require. In steady state it will be supplying. Only in the time of transients it will come into picture. Okay. So that we have shown it here, the waveforms, how it will work on it. You have seen like the torque in both the occasions. We have done some kind of PWM and all of them. The philosophy is that this is long time back we have done. So the philosophy is that like whatever we have shown in the previous circuit, the same thing will work only at the time of high pole, high poles, low number of phases, the 3-phase time. It will act as like a multi-level inverter, and this gives auxiliary inverter. That's what we call this. Our idea is that place a super capacitor here instead of battery that discharges faster. At the time of braking also, more braking happen at lower speeds, not at high speeds. High speeds very rarely we do it, sudden brakes. Suddenly some object comes. But more often braking happens within the city when you are driving at lower speeds. In lower speeds anyhow you have a number of poles. At the time of braking also, instead of making another alternate mechanism to this source, I can always drive that entire energy to it. That's all I am going to do it. Okay, add on to it.
We'll share this. So we will share this paper in the group, so you can prepare a summary, okay, for the assignment that we sent. So already 2 papers we have shared. This is the 3rd paper we will share. So I would like to thank Dr. Kumar sir for your really you hypnotized us on multi-phase system. We studied multi-phase, but after that we left at the first year basic electrical level only. So then we have not moved ahead. Multi-phase now we have to think seriously, because we saw 3-phase and we are practicing 3-phase everywhere. Because at that time 3-phase was more beneficial compared to single phase. But now we have to think multi-phase systems with respect to present context. Okay. So thank you for enlightening us on multi-phase systems, sir, and thank you for your visit, and definitely the research what you have done definitely will give motivation to others also. We will do a lot of things superficially as you told.
No, sir, no.
We have to
Everyone is doing the same, sir.
to what level of depth we have to go, that you have given a